Hey there. It's later than the last one that I did. Uh, Mr. McAndrews was here, so we were chilling. So, folks, you're tuned in for lesson 23, solving two-step equations. Oh boy, we've done one-step equations with adding and subtracting. We've done two one-step equations with multiplying and dividing. Now it's time to combine stuff. Oh yeah. And right, let me start with that concept that we talked about a while ago about building equations, and then maybe you'll kind of catch on to what's going on here with solving, excuse me, two-step equations. Let's start with what I had on that previous episode, x equals 42. And then we said, well, if we're ever going to change this, we're going to have to build it up one piece at a time by doing the same thing to both sides. So let's do some of that, okay? I'm going to rewrite this a little bit differently. I'm going to move that 42 to the other side and have x minus 42 equals 0. Okay, I am kind of building this up a little bit because what I just did was I subtracted 42 from both sides. Next thing I could do would be I could multiply. Okay, I can multiply. So maybe I'll go ahead and multiply everything here by 2. That'll give me 2x minus 84 equals 0. And so because I just took 2 steps there, I did some subtracting, I did some multiplication. To get back to x, I'm going to have to do 2 steps to get there. And though I could do this in a couple different ways, I could follow the reverse path. If I started with a 2x minus 84 equals 0, my first instinct would probably be to move the 84 back to the other side. That is to add 84 to both sides. Okay? I could, instead of multiplying by 2, I could divide by 2 or factor, and then go on to the other bit and totally undo everything. But here's what I would do in 2 steps. I would add 84 to both sides and get 2x equals 84. And then I would divide both sides by 2. And then that gets me x equals 84 over 2, or I get back to where I started from. Now the point here is that I took 2 steps in building that equation, and it took me 2 steps to get back. The 2 steps in building were subtraction and multiplication, and the 2 steps to get to undo that was addition and division. Okay, do you see how that goes? We're using opposites. We're using inverse operations to undo this built-up equation in order to get back to the solution. I think we oftentimes think of the whole problem being like a 2x minus 84 and starting there. But I think it's really good to kind of start with a solution and build something up and then undo that on the way back. Okay? You could have gone division and then subtraction, but in general, probably what I would call like reverse Pemdas, the reverse order of operations, might be a really good plan of attack. Instead of Pemdas, it's SADMEP. Oh, SADMEP. Poor guy. Have a name like MEP. Put that up here for you. But I'll do it this way. Subtraction and addition are the same level of things. Division, multiplication are the same level of things. Exponents, parentheses, those are like inclusion types of things. We could add in there the roots and powers. We could do that. But we'll just take this here that whatever 2 steps that we would have done to build up an equation are the same 2 steps, but just in reverse order that we're going to have to do to get back. And we're going to use the inverse operation to do that. Does that make sense? You can nod, and I'm never going to know, or you can give me a strange expression. I won't ever know. Another way to think of it would be Legos. And I don't have any here, but you can imagine some Legos, or you can go get some Legos or something like that. Okay, so you start off by putting a bunch of Legos together. Say you're doing it in a stack, right? In order to undo those, you're going to have to take the first one off the top, then those ones. So you're going to do everything in reverse order in which the way that you connected it. Sometimes pieces are connected and sometimes they're not. So you're going to have to undo it the same way that you did it. You can't pull out a piece because they're snapped in together if they come in layers. So let me do a couple that are kind of like what we've got here. We have 4x plus 5 equals 17. This one is one that it would be really, really clunky and hard to go and do the division to undo that 4x, that multiplication there. It would be really hard to start with division, right? It doesn't make a whole lot of sense if I'm going to try to isolate x or get x on one side all by itself. It doesn't make sense for me to try to undo that by dividing by 4, because everything in here would have to be divided by 4. And that leave me with x, but leave me with 5/4 and 17/4, and that's pretty clunky. So what do you think is probably the easiest thing to go after first? And you look up at SADMAP, and SADMAP says, well, if there's addition, I should do subtraction. Okay, now what should be subtracted? Well, one thing you're going to look for is on what side of the equation is x. And basically your job is to get everything that's not x to the other side. So I don't want to move that 17 over here. I don't want to subtract both sides by 17. That's not really helping me. That leaves me with a number over here and 0 over here. So what I need to do is need to move the 5 that way, and then I'll have to get the 4 over there somehow too. So let's undo the addition by using subtraction. That gives me 12 over here. That's 0, so it leaves me with 4x. And now everything's multiplication. And so if I'm going to do one thing onto the other, if I have multiplication, the way to undo that is going to be with division. So if this is multiplied by 4 and I want to get x all by itself, I'm going to divide by 4. And if I do it onto one side, I have to do it to the other. 1x equals 3. So we had addition and multiplication. We use subtraction and division to undo that in that order to get to our solution. Okay, let me go to one with one additional twist, and that would be something that has a negative coefficient. Oh, what do they got here? M. Let me talk you through two ways to do this. One will be the obvious. The obvious deal is we want to isolate M, so we're going to use the same process. It doesn't matter that it's on the right side. It doesn't have to be on the left side for us to solve it. Okay, we can have M equals and a number over here. That's totally valid in math because of the equivalence theorem. So if we want to get everything away from the M side of things, then we're going to have to get that 6 over here, and we're going to get that negative 5 out of there too. So you look at SADMAP, and SADMAP says if there's addition, the plus 6, the way to undo that's going to be with subtraction. I'm going to subtract 6 from both sides. And now we have the negative 5m's all by itself, and over here we got 8 minus 6 is 2. Okay, that leaves us with division, and to get the whole thing out of the way, let's just do negative 5. If we divide both sides by negative 5, then the negative 5 divided by negative 5 is 1, so that leaves us with m, and m equals 2 divided by negative 5, which is just negative 2/5. We leave it like that. There's nothing else to do. Just verify that we did it right if you want to by plugging that back into here. And that gives you 2 plus 6 equals 8, which seems to be sensible. Now I said I was going to do this in two ways, so let me show you what else you can do. If you're a little uncomfortable with that negative being there, You are allowed to do this step prior to doing other stuff, and that would be to move this over to the other side. And the way that you do that is that you're going to add 5m. If you do it to that side, you got to do it to this side. So you can move 5m to the other side and get 5m plus 8, or 8 plus 5m, it doesn't matter, equals 6. And now everything is positive, if that's what you prefer. And then to undo this equation, which is equivalent to our original, you would have to subtract 8 from both sides. 5m equals negative 2. And then divide a positive 5, so that negative's already over there, and we end with that m equals negative 2/5 again. So if you prefer to just kind of make everything a positive, you can, but you're going to have to move things from one side to the other. But don't be freaked out by the m or the variable on the right side. It doesn't have to be on the left side for you to be able to solve, though that might simplify things for you a little bit. Right. We got to watch out for if we move everything to one side that it leaves a 0. And then they got one more thing here, and that's with fractions. Now we're going to be coming up on decimals and how to fix those. Let's throw a fraction in there as well and just tease it out a little bit. Fractions scare you. Fractions scare most math students. They're smaller than 1, so you know they're just the little tiny things. Lots of these are. Okay, same thing. I want to get n all by itself, right? Remember the word for that? Is to isolate. So we're going to do that by undoing subtraction by addition. That means we're going to have to do some math here with this 3/4 plus 1/3. I'm just going to put that in parentheses right now and say that would be one math problem. Then how do we get that 1/2 out of there? Okay, what operation is going on here? 1/2 n. That's right. This is like Blue's Clues, isn't it? That's right, that's multiplication. So we can either divide by 1/2, which sounds weird, or do you remember what it is when you multiply? When you divide a fraction, what are you doing? You're going to multiply by its reciprocal. So if we multiply this by its reciprocal, then we can finish that one off. Those all cancel out, and you'll be left with n. You get that sum right there, which is 12, so that's 9, and that would be 4, 9, and 4 is 13. 13 twelfths times 2, which would be 26 twelfths, or and 13 sixths, or 2 6. Yeah, whatever. There is a better way to go about a problem like this. Let me show you what that would look like. I think this is going to come up in a later lesson, so this is a bonus material. It would be to look at all these and say, oh, yuck, fractions are disgusting. Let's get rid of fractions by multiplying both sides of this equation so that I can get rid of fractions. I find the biggest denominator there. I'm going to say, well, if I multiply everything by 4, no, that's not good enough. I got to do it by the least common multiple, whatever, first common multiple. 3 times 4 is 12. So if I multiply everything by 12, if I multiply 1/2 by 12, I get 6. If I multiply 1/3 by 12, I get 4. And if I multiply 3/4 by 12, I get 9. Okay, and that looks a lot nicer than that original business there. I basically did multiply both sides by 12. I multiplied everything by 12 and maintained the relationship between the parts, but come up with something that's just now whole numbers where I can do addition and then division, clean that one up. Just a suggestion, you can try it. If that doesn't make sense, that's fine. You can wait till a later lesson because we'll go over that method in much more detail. Hope that's enough to get you going on lesson 23. Have a nice day.